Hey everybody, as we move on in chapter 6, you're going to see that we are going to start seeing linear inequalities. Now, before I move on, if you notice something about this video, it's probably because there's dogs barking in the background or something. I'm outside with Molly, so if you hear dogs or whatever, it's just because I'm outside with my puppy, okay? So linear inequalities is probably exactly what you're thinking. We're going to have linear, meaning we're going to have a straight line. And inequalities means that we're not going to see an equal sign anymore, okay? Inequalities are things such as greater than, less than, greater than or equal to, or less than or equal to, okay? You're going to learn how to graph these. Honestly, it's not that hard. I think you're going to do a really nice job with them, okay? We're going to apply them to some real world situations as well, where you can see where this might be applied. So a linear inequality in two variables, can you put an S in that? It's just like a linear equation, okay, and you know that usually is, oh, I wrote the word equation twice, oh well. Just like y equals mx plus b, except it doesn't have an equal sign anymore, it has an inequality symbol. I hope that dog isn't too distracting for you. An example would be y is greater than 2x minus 3. Or maybe it's not in y equals mx plus b. Maybe it's like 2x plus 5y is less than or equal to 10. Okay? Those are two different examples for you. Now, a solution to a linear inequality, just like a solution to a linear equality, is a point xy that makes it true. For example, if you had 2x plus 3y, if you had 2x plus 3y is greater than 18, any xy point could make that true. Now, if that was an equal sign, you'd have to be pretty specific. But we have a ton of options here. For example, if you plug in 7 for x and 3 for y, you would get 2 times 7 plus 3 times 3. Well, that would be 14 plus 9. Well, 14 plus 9 is greater than 18. So any point, so I'm going to write and many more, any point that would make this true is a solution to this inequality. So let's just start real nice and easy on problem 1. Is the ordered pair a solution of y is greater than x minus 3? So we're going to take our x and y, and we're just going to plug them in and see if we get a true or a false, okay? So instead of y, I'm going to say is 2 greater than, instead of x, 1 minus 3. Well, that's like asking, is 2 greater than negative 2? Absolutely. So we say yes, it is a solution. And then part B, we just need to practice with our negatives. Remember, points are x, y. So we're going to do negative 7 and see if that's greater than negative 3 minus 3. We're just plugging in x's and y's. That's like asking, is negative 7 greater than negative 6? No, that is not true. Okay? So that's pretty much that simple. You just take a test point and see if it's true or false. Okay? Moving on. Let's try it one more time. If you want to pause the video and try the got it yourself to see if you get a true or false, go for it. Part A. Is 3/6 a solution to y is less than or equal to 2/3 x plus 4? So I'm going to take I'll do part A over here. So I'm going to take the y and do is y less than or equal to 2 over 3 times 3 plus 4. Plug in x for x and y for y. So I'm going to say is 6 less than or equal to 2 plus 4. So you tell me, is 6 less than or equal to 6? Absolutely. 6 is equal to 6, which makes this true. Okay. And then part B, it says, suppose an ordered pair is not a solution of y is greater than x plus 10. Does it have to be a solution of y is less than x plus 10? So they're pretty much saying, well, if it doesn't fit the greater than equation, does it have to fit the less than equation? What do you think? If you don't think too hard, you might be tempted to say, yeah, that makes sense. If it's not greater, then it has to be less than. But actually, we're going to say no. Hopefully some of you thought of this. No, because it might be equal to it. Okay, so it might be y is equal to x plus 10. So just remember, just because it's not greater than doesn't mean it has to be less than. It could be equal to it. Okay? Let's move on to problem 2. What is the graph of y is greater than x minus 2? Now guys, you should notice this looks just like a y equals mx plus b formula, right? Except it's not a y equals mx plus b formula. It's a y is greater than mx plus b formula. So we're going to go ahead and graph this very typical of what we used to do. Okay? So we find the y-intercept, we find the slope. The y-intercept, just like it used to be, is -2. The slope, just like it used to be, is 1 over 1. That's nothing new to you. Alright? So let's go ahead and plot these points. Now, don't get ahead of me so much that you're plotting points and connecting your line. Please pause after you plot your points. First go down -2 on the y-axis, and from that point you rise 1 and run 1. Rise and run, rise and run, rise and run. That looks pretty good. I've got 4 solid dots. I only have to graph 1 line, so I don't need more than 4 dots. Now, since this is not equal to, and you might want to write this down, it's the first time you're learning this. Since this is not equal to, okay, I'll just write, since it's not equal, we use a broken line to indicate our line is simply a boundary. Okay? Our line, write a comma, our line is not a solution, or it's not part of the solution. Okay? Molly just ran over to the neighbor's yard. Okay, Molly, come on. What are you doing? Okay, sorry for the interruption. So what we're going to do is we're going to connect these dots with a broken line. And our line indicates, since it's broken, it indicates that it's a boundary line. It doesn't, the values that are on this line aren't actually solutions. It's just the values that are either above it or below it. So you might be asking, Mrs. L, how do I know? Are the values above it a solution, or are the values below it a solution? Well, there's 2 ways to try this, okay? And I'm going to show you the long way, and then we're going to teach you the shortcut way. But just so you know, Mrs. Miles someday is going to ask you if you were ever taught this, and you're going to say, yes, you were taught the long way, okay? So here you go. Here's the long way of testing whether it's above or below. You check a point, okay? You check a point on the graph and see if it's a solution or not. So you see 0, 0. 0, 0 is a very easy testing point, and that's what we write. We write testing point. And 0, 0 is very easy to test. Okay? So I want you to write 0, 0. Now let's plug it in. So we're going to say, is 0 greater than 0 minus 2? And that came from our equation above. Well, that's like asking, is 0 greater than -2? The answer to that is yes. Now 0, 0 is a solution, okay? Yes, 0, 0 is a solution. What that means is that wherever 0, 0 is, like above or below the line, I hope you agree that 0, 0 is above our line, we have to shade everywhere above that line. Now, if you don't believe me, pick another point up here. Anywhere above this line is a solution. Now, if you wanted to check the opposite, you could check something down here. Anything down here would not fit this inequality. Okay? But you might say, Mrs. L, I remember you said there's an easier way. What is the easier way? The easier way is simply this. It was a greater than sign, right? If it's a greater than sign, comma, you simply shade above the line, because that is where y would be greater than the line. And a lot of people might have struggled, like, well, where's above? Where's below? Pretend the line is falling, and wherever it's falling at, that's where above and below comes into play. Let's try the got it and see how you do. We find your y-intercept, +1. We find your slope, +1/2. We graph it just like we normally would, but don't connect, and we'll talk about if you should connect with a solid or a broken line. So you go up 1, and then up 1 over 2, up 1 over 2, up 1 over 2, and you got a pretty nice graph there. Now I'm going to use a solid line this time when I connect. Why do I use a solid line? Because my inequality is equal to this time, because it says it's less than or equal to it, which means my line is actually part of the solution. Okay? So by making a solid line, I am indicating that my line is part of the solution. My line is part of the solution. Now, for those of you who are you like math and you're really trying to figure this out, here's what that means. If you take any point on your line, for example, this one's 1, 2, 3, 4, 1. If you take this point, 4, 3, the point that my pencil's on, if you take 4, 3 and you plug it in, you would get that this side, when you plug in 4, you would get that this side equaled 3. And since it equals 3 and this has an equal to sign on it, that's allowed. If you didn't follow that, you can try to replay it and try to figure that out again. But I hope it made a little bit of sense. Now, are you going to shade above or below, right? That's the question. Are you going to shade above or below? Well, we can do a testing point. And remember the easiest testing point I told you? The easiest testing point is 0, 0. Well, let's plug 0, 0 in. Is 0 less than or equal to 1/2 times 0 plus 1? Well, you tell me. Is 0 less than or equal to a +1? Yes, that is true. So whatever side of the line 0 is, you see zeros on this side of the line, it's below it, that means you shade on this side. Anything in the shaded area is a solution. Anything not in the shaded area is not a solution. Molly's chasing a bug now. Don't chase bugs. Don't chase bugs. Okay. Now what we're going to do is we're going to talk about the easiest way to decide if it was above or below. Can you guys see how it was a less than sign? Yeah, I know it was less than or equal to, but can you see how it was less than? That means that you should shade below the line. All the y values below the line would be shaded. So that's an easier way of seeing it. But like I said, someday Miss Miles is going to ask you about this. And because we're so used to the easy way, just try to remember this, okay? Because you might need that later on. Alright, moving on. These ones bring you back to when you guys learned about whether something was a horizontal or whether something was vertical. Now, I have a feeling you remember it even if you don't think you do. Sorry, I know my arm's in the way. Give me a second. Okay. Do you remember how to graph an x equals -1 equation? Well, x equals -1. Why don't you guys guess? Which one of these is an x equals an equation? An up and down line or a left and right line? Oh, sorry, you couldn't see that. If you can remember, an x equals equation is an up and down line. You're thinking, if you guys were thinking that was a horizontal line, that's because you were thinking, oh, that's the x-axis. But let me explain why, okay? Please on this graph go to where, notice there is no y. That's probably important to notice. Go to where x is -1. It's right here, right? Now, where is x -1? Along this whole entire line that I'm drawing. Now, why am I drawing a broken line? I am drawing a broken line because it is not equal to. Now you should notice that I have to use that broken line, okay, because it's not equal to. Now you might be saying, well, where in the world am I going to shade, Mrs. Landelia? I can't see that this line is really falling down, so I know that it's greater than. By the way, it's broken because it's not equal to. I know it's greater than, so you have to shade above the line. Well, what does that mean when your line is up and down? That means you shade all the x's that are above this line. So this is the only time you're going to deal with left and right. All of the x's to the right are in the positive direction. So you have to shade the x's on this side of the line. And you want to get as close to the line as you can with not crossing it. Okay? Let's do the y equals real quick. Now, since I told you that x equals is vertical, y equals is horizontal. If you're having trouble with that, let's look at the graph. Let's go to where y is 2. 1, 2. If I asked you to make a slashy mark, your slashy mark will go like that, wouldn't it? It would go sideways. That's because this is where y is 2. This one is a solid line. Because it is equal to my boundary line. And you see, so we use a solid line because it is equal. And can you see how this one's also greater than? Well, it's like asking, well, where in the world is y bigger than 2? Up here. The y-axis is bigger than 2 up here. Okay? Let's do the next two real fast, and then we'll start a new video for the word problems. Okay, x is less than -5. You count over 5 on the x-axis. You know that's your x-axis. 1, 2, 3, 4, 5. You draw a slashy mark. This one is broken because it's not equal to. You might want to write that down. And it says all the values smaller than that. Since it's less than, you shade over here. One more. Y is less than or equal to 2. You go to where y is 2. 1, 2, draw a slashy mark. Since it's equal to, we draw a solid line. But this time it says where y is less than the -2. You shade below. Alright, we'll do a new video for our next upcoming word problems.